Hey, welcome again to Data Beats. If you haven't already, do subscribe. Today, Kyle Kirwan, the CEO of Bigeye, is here to answer some questions about data observability yet again. So let's jump right in. Hey, Kyle, thanks for joining.
Hey, Arpit, thanks for having me on.
Absolutely. First question for you, Kyle. What is the simplest definition of data observability?
I think the simplest way to describe it would be to say that you understand what's happening inside your data pipelines, not what is happening about the pipeline infrastructure, which I think maybe we'll talk about later. But can you understand what's happening inside your pipelines? Do you understand the state of your data, and in particular, for most people, do you understand when something is wrong with your data, and can you pinpoint where and why something might be wrong with it?
Right, cool. That makes sense. Okay. So are the terms data observability and data monitoring interchangeable?
Not quite. They're definitely closely related. So the difference is that data observability is a state which we want to get to, right? So if I say, for example, that across all my pipelines, I have data observability or I've achieved data observability, then what it means is that I have all of the monitoring in place so that I understand what is happening inside my pipelines. So the monitoring is a step or a tool on the path to having data observability. So if you have the ability to observe what's going on inside all your pipelines, monitoring is the interface between you and being able to consume that observability information. So if we have, for example, a whole bunch of metrics and logs about what's going on inside our data pipeline, but we don't have any monitoring in place, it's very difficult for a human being to consume any information and benefit from that observability. So they're not exactly the same thing. They're not quite interchangeable, but they're definitely very closely linked.
Got it. That makes sense. Thank you. So there's a fair bit of confusion in the data observability space. So let's change that by defining some common terminology, right? So let's start with data infrastructure monitoring.
Yeah, so data infrastructure monitoring would be understanding what's happening with the machinery that's processing the data in each step of your pipeline, right? So, for example, um, is my data warehouse up right now? What is the response time to a given query? Are my jobs in Airflow running? Did a job have a failure? If a job has a repeated failure, that might cause a problem to the data that's flowing through the pipeline because we're not processing it, right? So data infrastructure monitoring would tell you, is Airflow working? Are the jobs running? Was there an error? So how is the sort of physical machinery working? So if we were to think about an oil pipeline, I know oil is a common analogy for data. We'd be thinking about the pipe itself, motors that are pumping and moving the oil down the pipe, not about the oil, which is what data observability or data monitoring would be focused on.
All right, cool. Yeah, that's a nice analogy. So what is data pipeline monitoring?
Yeah, so a data pipeline is a really interesting term. I was just talking to somebody about this recently. So I think when most people say a pipeline, they have an idea of what they mean, but it's actually a very vague term, right? So it generally means what is the series of steps that the data goes through from origin to wherever it's ending up, right? So maybe it's going into an analytics dashboard, maybe it's data that's being served, by a predictive model or something like that. But when we look at an overall system, where is the pipeline is actually a difficult question because a lot of times we have data from a whole bunch of different places. It's getting crisscrossed, it's getting merged, and at least in any company that's been around for a while, the graph of your quote unquote pipelines is really really messy or interconnected, right? And that's a good thing because you have data coming from a lot of places and going to a lot of places. It's not necessarily bad. But if we were to talk about monitoring a pipeline, what we need to be able to do is trace the flow of data up and down from one specific point of interest. So if I'm looking at a particular table somewhere in my data environment, if I want to look at the pipeline of data that's related to that table, we need to look at all the upstream dependencies where it comes from. And then we'd also need to look at all the downstream children where that table eventually flows to. And that might ultimately go into user queries, SQL queries, might go into a reverse ETL tool and out into HubSpot or Salesforce. It might end up in a Tableau dashboard. It might end up in DynamoDB where it's getting served by a model. So when we talk about pipeline monitoring, I think what most people are describing is some form of the ability to isolate a particular trace in their lineage graph and then overlay on that trace various attributes of importance. So, like, what is the freshness, and do we have a particular step in that pipeline where that step is not running on time, or the data that we see is not as fresh as it should be? Or do we see the volume of rows moving through a pipeline suddenly drop off in an unexpected way? So when I think pipeline monitoring, I think about all those questions about freshness, volume, row count, nulls, duplicates, but layered on top of the lineage graph and then isolated to a specific path that is important to the user.
Right. You mentioned lineage graph twice. So can you briefly describe what is data lineage and how does it fit in the observability stack?
Yeah, great question. So lineage is, I mean, probably a word everybody's heard plenty of times at this point, but it is that path uh, from some upstream point. So you could trace lineage starting from raw data that lands into the warehouse. Obviously, that comes from somewhere else. So we could go further upstream outside of the warehouse and trace it up to a transactional database. Could be Kafka topics that are getting loaded into, let's say, Snowflake. It could be all the way up to what is emitting messages into those Kafka topics. So what are the message producers that are on the other end of that pub sub? So the lineage is the map of where is the data emitted from, where is it flowing through, what are all the steps that it goes through, and then all the way down into some final destination, if you will. So as I mentioned with reverse ETL, that might be pushing it down into some target system like Salesforce, which might in turn also be the other end of the start of the lineage graph. So it may often be cyclical, right? But it is that map of what are all the different interconnects, what tables get joined with what other tables, and ideally it tells you information about, hey, here the data is messages in a Kafka topic, here the data is rows in a table in the raw layer in Snowflake, here it is data that's been aggregated by a dbt job, and it's being able to trace the data through each of those steps.
Right. And where does lineage fit into observability? Is it like an inbuilt feature of observability tools, or do companies use an external tool, like a separate tool for data lineage to view that graph, or how would you sort of fit it into this overall observability stack, like I like to call it?
Yeah, I think Lineage, you may know this, but I was the PM of the data operations
Yeah.
tooling team at Uber. And back there, Lineage was not a product, or it wasn't really like part of data observability in an explicit way. It was a metadata service that would collect and crawl the lineage graph by parsing queries. And then it would expose that graph via API to other products and services that needed to consume the lineage graph. So the data catalog could consume the lineage graph to display the relationships when you were looking at a table in the catalog. The data quality system could look up what the upstream dependencies were. So if we flagged a problem on a particular table, we could say, there is a problem in this table, but there are also problems in the parent tables. So the problem may actually reside further upstream than the table you're looking at. So in that case, the lineage was not necessarily like part of the catalog. It wasn't part of quality. It was this distinct metadata service with no interface on top, no UI or anything. But then other products could consume the graph out of it. I think what's interesting in sort of the modern data stack is each individual product sort of needs some form of lineage built into it. So someone may have lineage being collected from their catalog, and then they may also be using, Bigeye, for example, for their observability, and they may be getting a second lineage graph from that tool. So I think there's actually an interesting challenge here where lineage could be part of observability. It could definitely be part of your catalog as well. And if you're using multiple tools that each include lineage, you're going to have to figure out how to reconcile those.
Right. I was going to skip this question, but I'm still going to ask you. There are some observability tools that also have some lightweight cataloging features, right? Do you think eventually there will be like a single data quality solution that sort of caters to all of these different use cases, or do you think like a best of breed, purpose built solution is the way to go?
It's a good question. I think that a catalog, in its most basic form, is kind of a design pattern that you're probably going to end up finding in many different tools in sort of this data operations space, right? What tables do I have? What schemas are they in? What columns are there? What are their types? These are common challenges for any interface where you need to understand what's going on inside a data environment. Now, a fully purpose-built catalog with documentation, with, like, for example, user comments or things like that, that is a product in and of itself. But the catalog, for example, we have a catalog in Bigeye, but it is really not designed to be a governance tool or a discovery tool. It is a catalog insofar as it assists with navigation and understanding what's going on inside the system. Um, to your question about best of breed, I'm a big believer in sort of the Unix tool chain approach to things, which is that I've got a bunch of different pieces. Each one has a specific function, but they interconnect, so I can arrange them as needed for a particular workflow or for a particular environment. I would argue that a catalog, an observability system, Lineage as an underlying metadata service, access controls, et cetera, I think that these really ought to be distinct components. Now, whether that means that those components must come from different vendors or not, I think is a different question. I think in an ideal world, there's a vendor who you can do business with, and that vendor provides each of these components, and you can pick and choose the ones that make sense for your particular situation and combine them. That way, you're not managing, 15 different SaaS vendor contracts. I think that would be the ideal scenario. But to need to procure one giant heavyweight tool that tries to do all of it, I think is also not something that a lot of teams are interested in.
Cool. That made a lot of sense. What about data testing? There are tools that are dedicated to like helping companies test their data, right? So where does that fit in?
Yeah, so this was testing is actually at Uber where we started, right? So we said, hey, like, something goes wrong, some person sees data that's like clearly not correct in an analytics dashboard, or the data is just missing from the dashboard. What do we do about it, right? And the first place we went was a test harness. And so the idea was, okay, let's write, a data engineer or a data scientist can write some conditions about the data. So must have the same number of rows as the parent table, needs to be reloaded every 6 hours, things like that. We'd write these bodies of rules, and then we'd run those on a schedule, and you would get a pass fail. Now, I think that those are very powerful, especially when you want to do certain things like, say, if I made a mistake and now I have some, explosion in the number of rows in a table because I did a full join or a cross join or whatever it is. In those conditions where now I've got like a ton of duplicate primary keys, stop the pipeline. I know that is a bad condition. It's a condition I can anticipate up front, and I know I want to put a very hard rule in place that tells the system what I want to happen. That's a great place to use a test, or as a warning during development for things that you can anticipate and know would go wrong. So tests are useful, and I recommend them to practically every company that Bigeye works with. Now, where we ran into a challenge with tests, and where I think a lot of other folks, are running into it or will, is that you can't write a rule proactively for every possible thing that's going to go wrong in most of the data environments that most people find themselves working in, right? I've run into tables that are 850 columns wide. I've run into environments where there's 10,000 plus tables in Snowflake. It's just not practical to ask a data engineering team to sit down and think about every single rule that they would want to construct, right? It's not time efficient. It's not what people want to do. So observability helps with that long tail of, if we just harvest metrics from every single column and every single table, and if we know the relationship between the tables, et cetera, and we can just crawl all this information with a machine, then we can do signal processing on that, and we can identify things that look interesting. I think that some of those conditions might then be good candidates to put a rule in place, to put a test in place for. But it allows you to have this sort of long tail safety blanket or dragnet, whatever you want to call it, for all those conditions that you would not think to test for, and which really aren't efficient to have human beings spend their time trying to anticipate.
Yeah, thank you for that explanation. Do data observability tools also monitor the data at rest? Whatever data is stored in your data warehouse.
Yeah, so I think that the majority of the tools today primarily function on data at rest, right? So as opposed to, hey, let's validate the data that's in a data frame, while it's being processed before we write the results from a data frame back into the warehouse. That's, at least as far as I can tell, that's a very uncommon, if not completely absent technique. Most of the tools that you'll find in the market today, Bigeye included, query the data at rest. Now, that could be in a staging layer before it gets promoted into production. But it is still materialized at some point, and stored inside the warehouse. And so what that means is that we can query it. And from that query, we can produce those aggregated statistics, and then we can do our anomaly detection on top of that. Now, if you are able to speak to a streaming source, so if you can, for example, if you have a Kafka consumer, you could potentially do reads and things like that and do this anomaly detection on the Kafka stream before the data lands in the warehouse. So that's definitely something I think a lot of folks are interested in. But most tools today do query the data at rest.
Thanks, Kyle. Last question for you. What's the one piece of advice you have for companies looking to get started with a data observability tool?
Yeah, I think the main thing is that there's no magic wand in pretty much anything in data, right? What a great tool can do a lot. It can create a lot of leverage. It can make it easier for people to work together. It can automate a ton of manual tasks, right? So these are the things that we work on building every day at Bigeye. What it can't do is the organizational process bits. So in particular, I think what's super important to my comment just a minute ago about the impact to the business, the data team or whoever it is that's thinking about observability needs to understand where is data in the health of the business. Are we talking about analytics dashboards for internal stakeholders, execs, VPs, whoever? Are we talking about data that's flowing to operational processes that's used by the sales team, for example? Are we talking about data that's used in an actual model in production 24/7 that's in the app that's customer facing? And understanding where is data being used in ways that are valuable to the business, but could also be a risk if they're broken. And having an inventory or having a deep understanding of those is, I think, the most important step in being successful with applying data observability, because the whole point is make those applications reliable so that the business can use data in these high leverage scenarios without worrying that it's going to break.
Awesome. Thank you so much, Kyle, for answering my question and sharing your insights. You have a great day.
Thanks, Arpit.
Help bridge the gap between data people and non data people. Join us on databeats.community.